Hi, my name is Karthik Uppal, and I have presenting the project under the name of IoT-based optimized WeatherSync smart irrigation control system. So, giving a little introduction about this control system is that this is smart and efficient solution for the irrigation purposes, like for integrating the IoT technologies with irrigation system that allows the farmers to control the irrigation system remotely, and it optimized the water distribution by utilizing all sensors and algorithms and optimizing all water distribution. It reduces the wastage and enhances the crop yield. Empowering the farmers. The main advantage of this control system is that it gives cutting edge technology to farmers, and the whole process of irrigation is automatic. The fundamental elements used in this control system is, first of all, we have sensors. As we can see, like in this diagram, we have moisture sensor that read the reading of the moisture that is available in the soil. And then I have used the weather forecasting uh, system also in this control system. By incorporating weather forecasting as a vital component, irrigation control system empowers farmers to make informed decisions, conserve water, and improve overall agriculture productivity. Also, I have cloud connectivity in this, like all data which is read by the sensors and temperatures, every readings, it will be persisted in the database, and further it will be connected in cloud, and the whole system is automated control, the integrating actuators and smart irrigation controller to automate irrigation schedules and water flow, ensuring its precise and timely delivery of water to plant on the basic needs. Also, it will be having mobile app interface for getting all notifications to the user when the irrigation is needed, like the water valve is open or water valve is closed, the fertilization is required or no, with all this information. Importance of moisture sensor. When moisture level drops below the threshold, the sensor triggers the irrigation to prevent underwatering and crop stress. Conversely, if moisture level are sufficient, the system can delay or skip the irrigation cycle, preventing overwatering and water wastage. So integrating all moisture sensors empowers the farmer with precise water management, resulting in enhanced crop yields and water conservation and sustainable agriculture practices. Real-time monitoring of moisture sensor placed near the crops en route. These sensors continuously measure the soil moisture, providing farmers with crucial real-time data for data-driven irrigation decisions. For weather forecasting, I have used poison distribution in rainfall modeling in order to predict the events of rainfall occurring during the period of 30 days. So with this model, as you can see, lambda expression has been used, which denotes that average number of rainfall events expected to occur within the given interval time. In this scenario, I'm taking 30 days, and it can be estimated from historical data or meteorological models, considering various factors like weather conditions and simulations. And I am considering the probability of this uh, rainfall occurring events as in between from 0 to 1. So I can show that on the further slides how I will be using this model to club it with irrigation in order to further optimize the system. And applications in weather forecast models utilize the Poisson distribution to predict the probability of rainfalls, as I have told, and atmospheric conditions and satellite images. And there are various factors that can also be contributed in the Poisson distribution for rainfall modeling. Working of control system, all the, as we can see here, all the readings will be taken from moisture sensor, the temperature, and all weather data, like for how when will be the rainfall be occurring, the events of the rainfall will be taken, and considering the threshold points of the moisture, humidity, and precipitation, and all the various factors of the for irrigation purposes. Once the values of readings, once the readings reaches the threshold point, the water wall will be opened uh, accordingly. For example, if the moisture of the soil is below 20, or the humidity has reached over 50, then water wall will be open, and once it has reached a certain level, the water wall will be closed. And as we have clubbed the weather data with this, it has drastically improved our system, and everything is connected with the cloud. So every data will be every readings, every weather forecasting data, every readings will be used for further future purposes, as it will be stored in the cloud as well. And however, if the system predicts rainfall or soil moisture level is adequate, then it postpones the irrigation process to avoid overwatering. Now we can see the simulation results here. Water is enabled when the soil moisture level reaches 20 and temperature reaches 50 degrees. So enabling water trigger irrigation, increasing soil moisture and furtherly decreasing the temperature. And as I have used the rainfall prediction probability here from 0 to 1, and you can see here the water is triggered here as the temperature was uh, near 50 and the moisture was less than 20. And here as well you can see the temperature was more than 50 and the moisture was near 20. And when the moisture was above 20 and temperature was below 50, we didn't need the watering purposes. And these are the rainfall occurrences, like these are the predictions of the rainfall events. Now comparison with the traditional system, my system has additional weather forecasting technology which optimize the irrigation process, but traditional system do not have the rainfall prediction uh, set in their control system. So it overcompensates the limitations of the traditional approach, like conventional systems reliance on the predetermined thresholds and historical data that lacks access to the weather conditions, leading to inefficiencies in irrigation timing and inability to anticipate further forthcoming rainfall events. So the if we compare how much water, how much efficient my system as compared to traditional system, it's with the data we can see here, the my system consumes nearly half of the water as compared to traditional system during the rainy season. As you can see here, 1, 2, 3, 4, 5, 6, 7. There are 7 events during with my system, and with traditional system there are nearly 14 to 15 events of watering. So it is much more efficient as compared to traditional system. For future prospects, there it can be further improved by including more data like pressure, wind speed, solar radiations to and adding all these models, and also for fertilization decisions, and integrating advanced data and analytics and machine learning to continually fine-tune decision-making process and adapt to term climate changes. And WeatherSync as stands as a sustainable and efficient agriculture solution with ongoing research amid the revolutionizing farming practices and contribute to an ecological, responsible, and food secure future. Coming to conclusion, the WeatherSync smart irrigation control system represent a significant advancement in water resource management and precision agriculture, and it is way efficient as compared with the traditional system. The advanced state space model effective monitoring of soil moisture and dryness levels, leading to quick and accurate responses to changing weather conditions. Simulation results demonstrate superior performance compared to conventional approaches and achieving remarkable reductions in water consumption and enhancing crop yields. That's as we have added the model of weather synchronized data with the help of poison distribution rainfall events. That's it. Thank you.